Okay, this video is going to go over the 4.4 practice for you guys. Question number 1, 1 over 2x minus 2 over 5x equals 1/2. Solving this by hand, you'd find the least common denominator, which is 2 times 5 times x. All those are in the denominator. So you're going to multiply every fraction by the least common denominator, LCD. What you do from there is you cancel out what is in common from the least common denominator and what is left over in the denominator. So you see this 2 and x can cross out the 2 and x down at the bottom. The 5 and x here can cross out the 5 and x, and the 2 can cross out, leaving you with the 5 and the 1 minus the 2 and the 2. Those are multiplied, by the way. So 5 times 1 minus 2 times 2 is equal to 1 times 5 times x, which simplifies to 5 minus 4 equals 5x, which gives you 1 equals 5x. And then you can divide the 1 by 5. You can say 1/5, or which is 0.2. Graphically, you can do the following. You can enter the left side of your equation into the Desmos. 1 over 2x minus 2 over 5x. I'll type that out for you so you can see how that's modeled. 1/2x. Then you do the right arrow, minus 2/5x. And then when you have a number, you got to put a y equals in front of it. So you do y equals 1 over 2. Otherwise, if you just put 1 over 2, it won't graph anything. So make sure you put a y equals if it's just a number. So if you zoom in on there, you'll see a point of intersection right there at 0.2. 0.2 is your answer. That's question number 1. Question number 2, 5 over t minus 3 over 12 equals 9 over 3t. So our LCD, well, technically not our LCD, but we're going to take the 12, the 3, and the t. We're going to multiply them together because those are all in your denominator. Put those all with each fraction, multiply them. We'll cancel out the t's, which you're left with the 3, 12, and 5. You cancel out the 12s, which we're left with the 3, 3, and t. And you'll cancel out the 3t, which you're left with the 12 and the 9. So you're going to have 3, 12, and 5. 3 times 12 times 5 minus 3 times 3 times t equals 12 times 9. Multiply it out, simplify it, use your calculator. It gives you 180 minus 9t equals 108. I'm going to bring the 9t over to the right side, add it, and then take away the 108. And that gives me 72 equals 9t. And if I divide by the 9, t is going to be 8. You can also graph this. You can do 5 over x minus 3 over 12. Use x in Desmos equals 9 over 3x. So I'll call the tx. And if you click around to it, you can see this point of intersection right here. That value of x is your answer for 8. So the value of t is going to be 8. Okay, 4.4 number 3. It's a little more involved. We have 2 over y minus 1 over y plus 2 equals 1/3. First, your LCD, you have the 3, the y, and the y plus 2. We're going to write that out. Multiply all your fractions by 3y, y plus 2. We'll cancel out, in this case, the y's, in this case, the y plus 2's, and in this case, the 3's. And so you have 3 times 2 times y plus 2 here, minus 3y times 1 equals y times y plus 2 times 1. So the y plus 2, and 1 are all left on the numerator. The 1 doesn't really need to be written in either of these. And then that simplifies. So that's going to be 6 times y plus 2, which is 6y plus 12. This 3y times 1 is 3y. And ignoring the 1, that's just y squared plus 2y. And the 6y minus 3y is going to be 3y. So you got 3y plus 12 equals y squared plus 2y. We want to get the quadratic all to one side. So we're going to subtract the 3y and the 12, and we're going to get y squared minus y minus 12. That's going to factor. Negative 12 factors to, you can multiply it by negative 4, positive 3, and those add to negative 1y. So your zeros will be y equals 4, y equals 3. Remember, zeros and factors are opposite signs. Now, pause, write that down if you need it. In the graph, you'll do 2 over x. Remember, you got to graph with x. So 2 over x minus 1 over x plus 2 equals y over 1/3. Again, this is just a number, so you have to have a y equals there to get it to graph. And on this one, you see there are 2 points of intersection. You have a -3 and a +4 intersect at that flat line. So both of those numbers are real solutions, -3 and +4. And you can see how it matches up with our handwork. So pause the video and write that down and make sure you answer the question. Okay, 4.4 number 4. We have 1 over p minus 4 plus p over p plus 2 equals 6 over p squared minus 2p minus 8. We want to first factor the p squared minus 2p minus 8. So -8, two numbers that multiply to -8, -4 and +2 will also add to -2. So p minus 4 and p plus 2, which happen to be the factors underneath your left two denominators, which are perfect. So we're going to use those as our denominator, replace it. See how I just kind of rewrote it? And our LCD is p minus 4, p plus 2. So we'll multiply all the fractions by p minus 4, p plus 2. We'll cancel out what they have in common from the denominators. And we'll circle what's left over. P plus 2, 1, p minus 4, p, and 6. And so that's going to be p plus 2 plus p squared minus 4p. We're going to distribute that p equals 6. So we get p squared minus 3p plus 2 equals 6. And I'm going to subtract the 6, make that minus 4. Now I have p squared minus 3p minus 4 equals 0. I'm going to factor that. And when I factor that, I get p minus 4, p plus 1 equals 0. And my zeros from there are p equals 4 and p equals -1. Now we have a dilemma here because the two numbers that we got, one of them matches your restriction. Your two restrictions are a +4 and -2, because if you plug 4 and -2 back into the original equation, you get 0 for a denominator. Well, you can't divide by 0. So this 4 ends up being one of your restrictions. We call that, it's impossible to do, so we call that an extraneous solution. Extraneous solutions are solutions you plug back in that don't work. So the only real solution is -1. So our real solution being -1, and our extraneous +4. It's not a real solution. So how do you get? You can't really get a extraneous solution from a graph. So again, use X when you graph it. Well, the original one had x squared plus 2x minus 8, or minus 2x minus 8. So if I put my original graph in here from the left side and the right side, I'm going to see them intersect. They don't intersect over here. And they don't intersect over on the left side, but they intersect one point right here at -1. They only intersect -1. -1 is your real solution. You can't really get the extraneous solutions from the original equation. What you want to do in the graph instead is you want to put the equation that you get after you get rid of the denominator. So once you do the LCD, then you could put, for instance, what I'm circling here into the graph. That'll give you both the +4 and -1, but you got to remember that the 4 is extraneous because it matches up your, plugged into your denominator gives you 0. So you can watch me do that here. 1 parentheses p plus 2, got to use x, plus x parentheses x minus 4. You do y equals 6. And well, you're going to see, if you zoom out, you're going to see 2 points of intersection. You're going to have that 4 and -1. But remember, the -1's the real one, whereas the 4 is the extraneous. This number right here is extraneous. And it's extraneous because in the original solution, when you plug that back in, you get 0. 1 minus 4 equals 0. So we don't really want to label that as a real solution. This is a real solution because you don't get 0 when you plug back in. So -1 is going to be fine. Okay, we're going to do number 5 in real time here. So number 5, just kind of watch how I work it out. I got x over x plus 2 And then I have plus 2 over x squared plus 5x plus 6 equals 5 over x plus 3. Now the x squared plus 5x plus 6, you got to factor 6 and 5. So what two numbers multiply to 6 and add to 5? That's going to be 2 and 3. And it's really just these two factors here. So we're going to write x plus 2, x plus 3. And that's going to kind of replace this here. So we're going to leave that as x plus 2, x plus 3. Happens to be our LCD. So our LCD is going to be written at the top. Again, we just multiply by the whole fraction. And then we cancel. So let's cancel out, in this case, the x plus 2's. You're left with x plus 3. Here we got all 4 of those cancel out. So all you're left with is the 2 there. Oh, and that's actually x plus 3. I forgot to circle that x. So there's an x on the numerator. So that's going to go out the outside. So x times x plus 3 plus just 2. And over here, oh, we can cancel out the x plus 3. So we have 5 and x plus 2. So let's work that out. It's going to be x squared plus 3x plus 2 equals 5x plus 10. And we're going to take the 5x minus plus 10 away. So subtract those, minus 5x minus 10. So we can get you 0. And so you'll have x squared minus 2x minus 8 equals 0. Let's factor that. So 8 is 2 and 4. And I want to make the 4 minus because they got to add the negative 2. So my zeros are x equals negative 2 and x equals positive 4. Now let's go back and check the denominators. So in our denominator, we have an x plus 2. Well, that's a problem, right? Because our restrictions are going to be negative 2 and negative 3. And again, when you plug that back in here, negative 2 plus 2, you get 0. So that's not good. So this is actually extraneous, which means the 4 is real. So that's how I do it by hand. I know it's kind of fast. I'll go back and play it at a slower speed or pause it and kind of take that in. We have our answers: 4 for the real, negative 2 for the extraneous. I'll again model this on a graph here. If you just graph the original expression, you're only going to get the real solution. And that's okay. If your question only wants the real solution, then you can do that. So x over x plus 2 plus 2 over x squared plus 5x plus 6, 5 over x plus 3. We'll do that in a new line. And you'll see them cross here at 4, right? They won't cross at negative 2. So you won't get that extraneous solution by the original graph. But like we did before, we can kind of go by what we have from our first step after we do the LCD without having to simplify it. If you really want to get the extraneous solution, I'm going to turn those off. You could do x parentheses x plus 3 plus 2 is equal to 5 parentheses x plus 2. And you'll see that graph intersect in 2 spots. Let me zoom in here. Negative 2 is one of them, right there. And then up here should be 4. So you can get the negative 2 and the 4, both the real and the extraneous solution, but remember, you got to plug it back into your denominator. You have to plug it back into your denominator to make sure you don't get 0. And then if you do, then that number is an extraneous solution. So that's one way you can get on the graph. All right, next question. Hey, look at question 6. You notice it doesn't have, it doesn't talk about the extraneous solutions. So you could, I guess, theoretically graph it first. And supposedly, based off my answer blank, there's going to be only one answer. And it looks like it's negative 0.75, negative 0.75. I don't think I typed anything wrong, so negative 0.75 will be your answer. Now, it seems too good to be true. So where does that number come from? For those of you that want to know, let's solve it out. So I'm going to factor the x squared minus 16. That's a difference of 2 squares. So that's going to be x plus 4, x minus 4. We're just going to rewrite that like that. My LCD is x plus 4, x minus 4. So we're going to write that on the numerator. Let's use that in black. And let's put that in parentheses and let's cancel some stuff out. So x minus 4s will cancel out here. We got a 2 and an x plus 4 hanging out. So that's going to be that part. Let's cancel all these 4 factors, and what I have left over is a 3. So plus 3. Down here on the right side, I have minus, and then x plus 4's cancel out. So negative 2 times x minus 4. So that's our equation. Let's distribute. Let's combine like terms. So that's 2x plus 8 plus 3 equals negative 2x. And the negative times a negative is positive, so plus 8. So 2x plus 11 equals negative 2x plus 8. Now we can solve that. I want to get the x's to one side. I'm going to add the 2x to the 2x. That's going to give you 4x plus 11 equals, those cancel out, 8. Subtract 3. I meant subtract 11. 8 minus 11 is negative 3. 4x equals negative 3. Divide by negative 4. Or divide by 4. Can't talk today. Let's just divide. Negative 3 divided by 4. Well, that's negative 3/4, or negative 0.75. So that is the right answer. Just one number. No extraneous solutions. Our restrictions would be negative 4 and positive 4. So you can plug that in. Okay, this one is question 7. Again, this one is one of the ones that wants the real and extraneous solution. So if you just need the real, you can literally just graph the left side and the right side of the equation using x, of course. And you can see that they intersect at 2. So the real solution is 2. So you got half of that. Now, to get the extraneous solution, we do got to rewrite this without the denominators. So let's go ahead and do that in number 7. It's going to be r over r minus 1 minus 2 over r equals 1 over r minus 1. Now, I don't have anything to factor, so my LCD is going to be r and r minus 1. So we're just going to write that on the numerator here. Multiply it by the whole fractions and cancel stuff out. So r minus 1s, r's, and again r minus 1s. So you are left with the r and the r. That's r squared. Minus 2 and the r minus 1. Equals the 1 and the r. So if you don't feel like solving the rest of that by hand, you're at the point now where you can just graph those two parts into Desmos. So you could say, of course, using x squared minus 2x minus 1, and you could say 1x. So when you do that, you can see this part here and that part there. You can see 2 points of intersection, 1 and 2. 1 and 2. Now remember, we had gotten 2 as one of our answers, which is fine. It's allowable because if you look at your restrictions, when you plug in 1 to there, you get 0. So 1 is a restriction. So your restrictions are going to be 1. When you plug in 0 there, that's also a restriction. But obviously our answers are 1 and 2. So the only restriction that we plug in is 1. That means that's extraneous. So I'm not going to bother solving the rest of that by hand, simplifying it and factoring it, because you can do that part in the calculator to get the extraneous solution. But just remember, what makes the denominator 0 if it's one of your solutions when you solve it by hand is an extraneous solution. I'm going to plug there that 1 back in for r. So this is going to be 2 and 1. Okay, question number 8. Let's start that from scratch here. This just wants to know the value of b. There's no extraneous solutions. So I'm going to use the Desmos graph to get the answer. B we'll call x. So we do the fraction bar first. Always hit the fraction bar first, especially when you have multiple things on the numerator. We'll say 2x minus 3 over x plus 6. That's this graph here, which we'll zoom out to see it later. And then the 3 over 2, we say y equals 3 over 2. Now we need to zoom out so we can see if these graphs intersect. And it looks like we found a point of intersection at 24. So 24 will be your answer. There's only one number here that they intersect, 24. So how do you do that one by hand? You do, let's see, this is number 8, or yeah, number 8. So we do 2b minus 3 over b plus 6 equals 3 over 2. Now you can actually just cross multiply here if you want. That's what I do. Since our LCD is, you know, it's 2 and b plus 6, you're really just putting the 2 up here. Like you could do the 2b plus 6, and you could do the 2 and the b plus 6. I mean, you can do that. You can cross multiply too, but the b plus 6 will cancel. So you're really just multiplying the 2 up here, and then down here the 2's will cancel. So you're really just multiplying the b plus 6 up here. So it's really going to be 2 parentheses 2b minus 3 equals 3 parentheses b plus 6. So it's just good old cross multiplication there. We're going to distribute 4b minus 3 minus 6. So 4b minus 6 is equal to 3b plus 18. So I'll take away 3b from both sides. And we'll get b minus 6 equals 18, at which point I can add the 6 to the 18. And b is going to get you 24, and I'm safe. 24 plus 6 is not 0, so your answer is going to be 24. Okay, question 9. What is a real solution of the following equation? So it doesn't ask for the extraneous solution. Must put it in the graph. 1 over x plus 1 minus 3 over x minus 1, and then equals 2 over x squared shifted 6 minus 1. And whoa, I got a lot of things going on here. Look for that point of intersection, and I see one right here. There at -3. So -3 is going to be my one and only real solution. Now there might be an extraneous solution, but this one doesn't ask for it. So -3 is your answer. For those of you who want to see it by hand, So we're going to first factor the x squared minus 1, and it's going to be x plus 1, x minus 1. That's a difference of squares. So I'm going to replace that with the factored form, make it easier. We'll do our LCD, x plus 1, x minus 1. Carry it to all three fractions. And just cancel. So those go out. Those go out. All four of those go. Let's circle what we have left. We got a 1 and an x minus 1. Minus, we have 3 and an x plus 1 equals 2. So this is x minus 1 minus 3x. And then this is minus, so minus 3 times 1 minus 3 equals 2. Those combine to 1x minus 3x, that's negative 2x. Negative 1 and negative 3 is minus 4. Add 4 to both sides. Negative 2x equals 2 plus 4, 6. 6 divided by negative 2, negative 3. And your restrictions are negative 1 and positive 1. So neither of those match your restrictions. Negative 3 is a real solution. It's the only solution, and which backs it up with the graph that we have here. All right, that's that one. That's number 9. Okay, we got another one of these real and extraneous solutions for number 10. I wrote out the equation. I'll go ahead and just see if I can get the real solutions from the graph. I'll put one side and the x, of course, call the y-x, one side in one line, one side the other line. Make sure you put everything in correctly. And it looks like I see a solution at negative 1. That's a real solution. So the original equation, when you plug in, you get that intersection, it's a real solution. So now remember, your extraneous solutions, honestly, is going to be one of these two numbers. It's either going to be 2 or 6, because those are your two restrictions. And when you factor this, these two factors, I mean, 12 is 2 times 6. Negative 2 times negative 6 is 12, and they also add to negative 8. So your factors are going to be y minus 2 and y minus 6. Full stop. So let's do our LCD. It's going to be y minus 2, y minus 6. We'll just multiply by every fraction. Let's cancel stuff out. That's going to be 4. Y minus 2's cancel out, so you have a y and a y minus 6 plus, and then the y minus 6's cancels out, so you have a 1 and a y minus 2. All right, so now we don't have a denominator. We can get our extraneous solutions. We can figure out what's actually extraneous. So I'm going to hide the original graphs, these complicated rational graphs. And I'm going to do instead the left side of my equation here, which is 4. So I'm going to do y equals 4, because you have to y when you do those. So y equals 4. That gives you a nice horizontal line up here. Otherwise, it's just a number. But a y equals 4 is a graph. Then you got to call x, so x parentheses x minus 6 plus 1 parentheses x minus 2. So anything you graph is x, with the exception, of course, y equals if it's just a number. So you have negative 1 as your intersection, but also 6. 6 is one of your restrictions, because when you plug it in, you get denominator of 0. So 6 is a restriction. That means 6 is extraneous. So one of your solutions, extraneous solution, is going to be 6. The other one, negative 1, is going to be a real solution. If you'd like to see me carry through with the rest of that problem by hand, just watch along, okay? So I would do the distributive property here. That's going to be y squared minus 6y, and then plus y minus 2. So 4 equals all that. So 4 equals y squared. My y's are going to combine to negative 5y minus 2. I'm going to subtract the 4. Negative 2 minus 4 is negative 6. So 0 equals y squared minus 5y minus 6. And from 6, I can get two factors. Uh, 6 and 1 will give me negative 5 if the negative is with the 6. So y minus 6, y plus 1. Your zeros are going to be, your answers are going to be y equals 6, y equals negative 1 when you get it from these factors here. But the 6 is extraneous because it matches up, plugs into your denominator, gives you 0. So that's going to be extraneous. And this one's going to be real. So a couple different ways to approach that. Both of them are shown. Okay, question 11 is 3 over x plus 2 equals x minus 3 over 2x plus 4. What's the real solution? Looks like it's 9. What is the real solution? The real solution is 9. By hand, looks like this. All right, so by hand, I have x plus 2, 2x plus 4. This can be factored out. This is 2 parentheses. You know what? No, I'm not going to do that. I'm going to keep it easy. So we're going to do x plus 2, 2x plus 4, x plus 2, 2x plus 4. Cross out the x plus 2's, cross out the 2x plus 4's, and we're left with 3 parentheses 2x plus 4. Cross multiplication equals x plus 2, x minus 3. All right, let's multiply together. So we have 6x plus 12 equals x squared minus 3x plus 2x minus 6. 6x plus 12 equals x squared minus x minus 6. All right, we're going to subtract from both sides. 6x minus 12. We're going to subtract 6x from both sides. So we got 12 equals x squared minus 7x minus 6. And then we're going to subtract 12 from both sides. We have 0 equals x squared minus 7x minus 18. Minus 18. So x squared minus 7x minus 18. What can 18 factor to? I'm thinking 9 and 2 can get me 7 somehow. And it sure can. It's going to be x minus 9 and x plus 2. Those are my factors. So my zeros are going to be x equals 9 and x equals negative 2. Here's the thing, right? Negative 2 plus 2, that's 0. Negative 2 plus 0 is 0. Plug it into my original denominator, I get 0. Negative 2 is extraneous. So 9 is why the only answer shows up here, because extraneous solutions do not show up on the original graph. So the real solution is 9. which is what we had over here. All right, number 12. What is this? The sum of the real solutions. That means there's more than one real solution. Oh, what are they? All right, I got this negative 1.5, shoot, and 2. Negative 1.5 and 2. Negative 1.5 and 2. Sum means add. So those add to 0.5. Negative 1.5 plus 2 is 0.5. All right, how do we do that by hand, you ask? Of course you would. Let's do it. What's our LCD? This doesn't have a denominator, so it's x plus 4 and x. So, well, if there's no denominator, you could say over 1 if you want, but that doesn't do anything. So what can I cross out here? Just the x plus 4s. So I have x and 6x. 6x times x. Nothing. The 1 doesn't do anything, so all these are valid. So 4x, x plus 4. That's all part of your equation there. And then here the x's cancel. So I have 2x plus 2 and x plus 4. So this is going to be 6x squared plus 4x squared plus 16x equals 2x squared plus 8x plus 2x plus 8. So I got 6x squared, 4x squared, that's 10x squared plus 16x equals 2x squared plus 10x plus 8. That should be right. That's a big number for x squared. I'm just making sure that's right. 4x, x plus 4. All right, well, that's what I got. So we got 10x squared. I'm going to subtract the 2x from both sides, 2x squared, that is. And I'm going to subtract the 10x. And let's see what I got. So I have 8x squared plus 6x equals 8. And then I have to subtract the 8 from both sides. So I have 8x squared plus 6x minus 8 equals 0. All right, let me bring all this up here for a minute. All right, so let's keep working with that. All right, boy, we got 8x squared plus 6x minus 8. I can factor out something from 8 and 6. They're both divisible by 2. So it's going to be 4x squared plus 3x minus 4 equals 0. So 4x squared plus 3x minus 4. How do we factor that? Well, let's see. 4x squared plus 3x minus 4. Well, that's not going to help me. All right, I messed up on that last problem big time. We're going to try this one again. Question number 12. Hopefully I'm able to cut that out, but if not, you had to suffer through the last couple minutes. My LCD is going to be x plus 4, x minus 1. So I'm going to cancel out the x minus 1s here and the x plus 4s there. I'm left with 6x and x minus 1, 4, x plus 4, x minus 1, and 2x plus 2 and x plus 4. So that's going to be 6x squared minus 6x plus, well, we got to do this part first. So x squared minus 4x plus x squared minus, let's see, 4, hold on, 4x squared minus x plus 4x minus 4. Double check me on that one, y'all mathletes there. It's going to be 2x squared plus 8x plus 2x plus 8. All right, so 6x squared minus 6x plus 4x squared. I'm going to combine these, so that's going to be 3x. So 4 times 3x is going to be 12x. And then minus 16. These will combine to 10x plus 8. 2x squared plus 10x plus 8. All right, let's see what else we got. We got 6x squared, 4x squared, negative 6x, 12x. So that's going to be 10x squared plus 6x minus 16 equals 2x squared plus 10x plus 8. Well, guys, we're going to subtract all of these from the left side. So that's going to give us 8x squared minus 4x minus 24 equals 0. Now, all three of those terms are divisible by 4. So I'm going to write 4 parentheses 2x squared minus x minus 6 is equal to 0. Now I want to factor 2x squared minus x minus 6, but I don't have to think about it. So I'm going to graph 2x squared minus x minus 6, and I'll get 2 zeros, negative 1.5 and 2. Of course, those are my answers, negative 1.5 and 2. But let me show you how to get those factors from there. First, the 2, that's the easy part, because that means one of your factors is going to be x minus 2. So the other one, negative 1.5, well, shoot, guys, negative 1.5, that's negative 3/2, so that factor will be 2x plus 3. Remember, the factor and the sign of the 0 switch, so put that 2 in front of the x. So that's going to be 2x plus 3. So these are the two factors of that. Set them both equal to 0, and you end up getting, oh, look, negative 1.5 and 2. When you combine those two together, since neither of them are restrictions, negative 1.5 and 2, they add to positive 0.5. Got all that from the original problem. All right, last few questions should be review. Let's get those done. All right, let's do these reviews here. X squared minus 4 over 16 minus x squared. You should be comfortable with this one by now. We've done it a couple times. Okay, what you want to do is you want to factor the numerator. So x squared minus 4 is a difference of squares. That's x plus 2, x minus 2. 16 minus x squared is a difference of squares. That's 4 plus x, 4 minus x. 16 minus 4x is a GCF. You take the 4 out, you're left with 4 minus x. And then the 4x plus 8 is a GCF. You take the 4 out, and you have x plus 2. So let's cancel some stuff. X plus 2 has a matching partner over there. 4 has a matching partner down there. 4 minus x has a matching partner down there. What we have left is x minus 2 on top and 4 plus x on the z bottom. All right, for those of you who wanted to use Desmos, put the all right, I gotta get this bigger. There we go. So parentheses, fraction, x squared minus 4 over 16 minus x squared, right arrow, close. Parentheses, fraction, 16 minus 4x, down, 4x plus 8, right arrow, close it up. Original expression. Answer choices, x minus 2 over 4 plus x. Fraction, x minus 2, 4 plus x. Boom, that's your answer. Right there, it overlaps. We got our choice. All right, next question. All right, division, let's do this. 5 over 2y divided by 5y over 2y plus 2. 5 over 2y divided by 5y over 2y plus 2. Keep, change, flip. So 5 over 2y multiplied by flip 2y plus 2 over 5y. Next, factor out. Greatest common factor, 2, y plus 1. Nothing else factors. So we're going to say 5 over 2y multiplied by 2, parentheses, y plus 1 over 5y. Okay, we can get rid of the 5s and the 2s. But the y's here don't cancel out because they're on the same side of the denominator. So it's going to be y plus 1 on the numerator over y times y, which is y squared. So it's going to be this one here. Here's how you put it in the calculator. Oh, I don't have Desmos pulled up. Let me do that real quick. So much stuff. Sorry. 5 over 2x. Let's do the division bar first. Another division, and then another division. So 5 over 2x divided by 5x over 2x plus 2. There's your graph right there. Let's put our answer choices in. 1 over x, no. 25 over 4x plus 4, No. X plus 1 over x squared. Yes, that matches up. Last question. You have been very patient if you've watched this whole thing. Holy cow. Good job for you guys. Okay. And let's go over it. All right, if you remember how to add, here's what we do. So how do we simplify that? What we're going to do is we're going to cross multiply. We're going to take this 4x plus 3, we're going to put it up here. Then we're going to take this 2x minus 3, we're going to write it up here. We're going to multiply it by the numerators of that fraction. That's going to get written over the combined denominator. So you see these 2x minus 3s and 4x plus 3s, they just get smushed together. So it's going to be 4x plus 3 multiplied by 3x minus 1 plus x plus 7 multiplied by 2x minus 3 and then we just write that over the two denominators, 2x minus 3 and 4x plus 3. So let's simplify, combine like terms, and see what we get. 4x times 3x is 12x squared. 4x times negative 1 is minus 4x. 3 times 3x is plus 9x. 3 times negative 1 is minus 3. Plus x times 2x is 2x squared. X times negative 3 is negative 3x. 7 times 2x is plus 14x. And 7 times negative 3 is a negative 21. Well, let's combine all those. That's 14x squared. Negative 4 and negative 3 is negative 7, plus 9 is 2, plus 14 is 16. So those four should combine to 16x. And then these are negative 24. And that gets written over 2x minus 3 and 4x plus 3. So what are your A, B, C? A is going to be 14, B is 16, and C is negative 24. There's your answer. Okay, well, there's your 100 right there. So there's 1 through, watch the video to get all of them, but there you go.